Welcome again to Grandad's Workshop. If you remember, last time we looked at magnets and I made the magnetic field visible by pouring iron filings around one of the magnets. And that's really important because we've made this invisible magnetic field, we call it, visible. Now, what I've done is I've done a drawing which takes a few of these lines and simplifies it so that we can see the actual pattern. You might like to look at that and that together. You can see there are lines going from the north to the south, like that. And these lines coming out of the north and lines coming out of the south. I've just chosen one or two of them to make it clear. Now, the interesting thing is the lines get so weak that they're just petering out. But if we actually follow that line, it would actually take us around, it would take us around, it wouldn't wobble like that, and that one would come around like that. So what we're seeing is the field stretches out into space. I suppose if you followed these ones along, that one would also come way out there to that side, and from the North Pole way out there back to the South Pole. Now what we do, we say that these lines have a direction. We say that they come from north to south. And just to show that, we put arrows on those lines and we call them magnetic field lines. That one must be coming that way, all the way around to the south. So that one must be going in to the south like that. This one is coming out from the north and coming back into the south. So it must be doing that. Okay, so that is our magnetic field around a magnet. Now, if you remember, when I was making magnets in an earlier video, I was always running in the same direction. So for instance, I can make my screwdriver into a magnet by following one of these field lines. Let's say we run it from south to north, around, following a field line, and back. And what will happen here is, because this screwdriver is made of steel, that'll be important later, the screwdriver is now a magnet. And to prove it's a magnet, I'll pick up one of these screws. Will it? Will it pick up one? I might need to run it a few more times. Oh, there we go. So this is useful because if you magnetize the end of a screwdriver properly, not like me, the screwdriver, if it's magnetized properly, can be used so that the actual screw doesn't drop easily off the screwdriver. You'd have to do it a few more times to get it absolutely right. Now, I want to just take a break from that for a few seconds and talk about different things and whether they are magnetic or not. Well, wood isn't magnetic. Magnets aren't attracted to wood, and many non-metals, most non-metals, are not magnetic at all. But some metals aren't attracted to a magnet. This one's brass. Brass is not attracted to a magnet. The same if I were to take aluminium foil. It's not attracted to a magnet. But what about these nails are not steel, they're iron. And iron's attracted to a magnet. And we know, of course, that steel, like the screw or the screwdriver, is also attracted to a magnet. But there's a big difference between steel things and iron things. What is it? Well, if you make steel into a magnet, it will actually stay a magnet. So let's just do our making a magnet again. And there we go. And this is a magnet, and it will stay a magnet. So it's staying as a magnet, and that's what we call permanent magnetism. It will attract things. There it is, lifting up the screw, and there it is, lifting up the nail. Now, let's try to make a magnet like that with iron. This is not steel, it's not the same stuff. This is iron. Let's try to make a permanent magnet with iron by rubbing it along the magnet and following the field line, like that. And the question is this a permanent magnet? And the answer is no. You can't make iron into a permanent magnet. You can make it into a temporary magnet, a magnet just while it's there, by sticking it onto a magnet like that, and up comes the other iron there. But if I take this off, it's not a magnet any longer. And that's what we call temporary magnetism. And that's really important. You might think that's useless, but it's really important, because switching off magnetism and switching on magnetism is really, really important for us. That's it. Bye.